So number 7 from the worksheet is asks you how many moles of hydroxide ion are required to raise pH of 4 liters of 25 millimolar glycine pH 1.9 to the final pH 9.7. So these questions first, you need to understand how glycine deprotonate, and you need to look at the structure of glycine and its pKa. So these show how glycine deprotonate. So glycine has only two pKa, 2.34 and 9.6. So 2.34 is the pKa of the alpha carboxylic group, and 9.6 is the pKa of the alpha amino group here. So, okay, so first you have glycine pH 1.9. It's fall right here. And then you need to raise the pH into the final pH of 9.7 here. So at pH 1.9, because this pH is like within 2 pKa unit from 2.34. So it means that at that state, the glycine will compose of two forms of glycine, either the first form or the second form. But at pH 9.7, similarly, the glycine will also contain two forms, the second form and the third form. So to calculate how many moles of hydroxide that are required to raise the pH from 1.9 to 9.7, you have to understand that first, at the first step, it would be raise the pKa from 1.9 to the point where the second structure is, and then the second step is to change further and raise the pH to 9.7. So since we understand that at pH 1.9, your glycine will contain the +1 form and the neutral form here. So because step 1 is the purpose of the step 1 is to change the +1 form into neutral form. So pH 1.9 contains glycine plus and glycine 0. So the ratio between acid and basic species here would be calculated by using the Henderson-Hasselbalch equation. So pH is 1.9, equal pKa is 2.34 plus log B over A. If you solve for B and A, you get the ratio of B equal 0.27, while A is 0.73. So how would the value of B and A here tell you how many moles of hydroxide that you would need to add? So because at this step, the purpose is to change glyce plus to glyce 0. So the ratio of the base here doesn't need to do anything with it. Only acid part is actually need to react with hydroxide ion, right? So only Glide plus will have to react with hydroxide ion to change to Glide 0. And at pH 1.9 here, we have 0.73 equivalents of glycine plus. So because one equivalence of glycine plus would react with one equivalence of hydroxide ion. So that's why we also need 0.73 of equivalence, 0.73 equivalence of hydroxide ion to react with glycine plus to change it into 0.73 glycine 0, and that will make all of the glycine becoming the 0 net charge. So step 1, we need 0.73 equivalents of hydroxide ion. What about step 2? So step 2, the purpose of step 2 is to change glycilo to glycine -1. So at step 2, pH 9.7, the purpose is to change glycine 0 to glycine minus. So at pH 9.7, that contain neutral form and negative form of glycine. And also, similarly to step 1, you need to use the Hansen-Hasselbalch equation to calculate the ratio of either the neutral form or minus form here. So the pH is 9.7 and pKa we use 9.6, and then when you calculate for B and A here, your B will be 0.56 while your A will be 0.44. So at pH 9.7, you have to have glycine minus form 0.56 equivalents. But in the beginning of step 2, you're starting from 100% of glycine 0 charge, right? So partially of glycine 0 charge need to be changed further into the glycine -1 form. So only the So how would we know the amount of hydroxide equivalents that need to be added in this step? So we can say that because we want glycine -1 charge to be 0.56 equivalents. So the amount of hydroxide that need to be added is also 0.56 equivalents because it needs to react with 0.56 of glycine 0 charge here to make glycine negative charge 0.56 equivalents. So to sum up here, it means that at step 2, we need hydroxide on 0.56 equivalents to change partially of the glycine 0 charge to 0.56 glycine -1 charge. And we use the value of the ratio here to calculate the equivalence of hydroxide ion. So in summary, to sum up from step 1 and 2, so it means that in total, you need 0.73 plus 0.56, and that is equal 1.29 equivalents of hydroxide ion. And because this is just equivalence here, so you need to compare the equivalence back to how much of the glycine that you have. So you have glycine 4 liters of 25 millimolar, and calculate moles of this glycine, you get 100 millimole. So if you need 1.29 equivalents of hydroxide ion, so it means that to calculate the moles of hydroxide, you need to times the equivalence by the amount of moles of glycine. So you get 129 millimoles or 0.29 moles of hydroxide ion.